In this video, we're going to demonstrate setting up a PID block in DeltaV 12.3.1 in Control Studio. So first off, we've got our DeltaV trainer over here. We've got a Fluke 725 wired to the analog input and to the analog output. You can see the wires go down, coil up to the Fluke 725 right here. So we have it set up to measure and source. So this source value is going to be sourced to the analog input. This measure value is going to be measured from the analog output on the DeltaV trainer. So you can see we also have our workstation connected here through our Ethernet jack to the back of our workstation down under there. And right here is the screen on our workstation of our Professional Plus workstation. So what we'll do is we're going to work with a pre-configured PID block. It's found by drilling down into Library, Module Templates, and then Analog Control, and this PID loop. We want to work with this. This is a standard kind of template that DeltaV provides. So to work with that, to put it into our control system, we can basically just drag it and we'll drop it into our default area, area A. So area A is always there when you create a install DeltaV. It's kind of a default. It's always going to be there, area A. Once we have it dropped into there, the areas are used to help sort. So if we had multiple control loops on, say, a skid, a compressor skid, or whatever, some sort of a process, we could call this compressor. And then all the loops associated with it would be grouped under it. And then what we need to do is we need to assign this loop, or this is what we call a control module. So in each area, you have a control module. And this is a control module. We need to assign it to a controller so it can be executed and the logic can be solved. So if I right click and I go to assign, sorry, I'm trying to video, and there we go. Assign right here at the bottom, or near the bottom. Click assign, and there's our controller. Our controller has already been commissioned. We've already set it up. You can watch another video on commissioning a controller. Controller set up, so we click OK, and it's assigned to that controller. It's giving us a warning. Are you sure you want to assign this module? Yes, we are. So it's been assigned. You can see some blue triangles have appeared now, indicating that there's been some changes. So actually under the controller here, you can see there's assigned modules. There's our PID loop 1. We're going to go ahead and rename this. Right down here at the bottom, rename. We're going to call it LIC-100. So I've already got two devices enabled on our system. On channel 0, on both our analog input card, we have channel 0, and our analog output card, we have channel 0 set up. You can see it's called LT100 and LV100. So this is a level loop. That's why I called my controller LIC100. Okay, so now we're going to open this control module up here by right-clicking and going open with Control Studio. So Control Studio is another piece of software used by DeltaV, and it's used for making logic changes. So right there, it's already got a block, PID block, dropped into Control Studio, and it's got some instructions on how to use the block. So we need to tell it which analog input and analog output we want to connect to it. So this is all function block programming. Click on out and drag it to in, and that will send the output of the analog input block to the in on the PID block, the out to the CAS in on the AO block, and the back cal out to the back cal in. So this last connection I just made is used for preventing reset windup, and helps with bumpless transfer in the control system. Okay, so we've made all of our connections for a basic control loop. Now we want to configure our PID block to demonstrate and verify that this PID block is actually working properly. There's a few parameters. You can see I clicked on this block, And down over here, there's a parameter list that's appeared. So these are the parameters we're going to be working with. The first parameter that I want to demonstrate is one called control options. So it starts with a C. You can see I've got the alphabetic tab clicked, so it makes it a little bit easier to find stuff if you already know where it is. The categorize groups things. So since I know what I'm looking for, I'm going to use the alphabetized tab. Control options, I double click on it, and over here brings up a menu of some settings we can change for our controller, or PID block. We want to make this a direct acting controller. If this is not clicked, it'll be a reverse acting controller. So for this demonstration, I want to use a direct acting controller. So that's all I need to change here. Click OK. The other thing I want to make a change to is our biasing right here, what our controller is biased to. So the biasing is the value that it's going to output when there's 0 error. So we want this to be biased at 50%. We want our control valve to be open 50% when there is 0 error. So it's set for 50. The next item I want to adjust is our structure, it's called. And you're going to see what that is in a few seconds once I find it. There it is, the structure parameter. Double click on that. This here's how we're going to change this to proportional only controller. There's not actually a setting for proportional only. This is the closest to it. P action on error, D action on PV, and we're not going to be using the D action, which is derivative, so we'll select this. For some reason, if we select these other parameters, they all have integral in them, and the integral seems to want to mess up this demonstration, so I want it to be proportional only controller. P action on error, D action on PV, we'll select that. Click OK. Alright, the last item I want to also configure actually is the gain setting. The gain set up for 0.5. Let's just make it easy to work with. We're going to make it a gain of 1. Okay. Got everything configured the way we want it. Now we've assigned it. You can also see, you can assign this control module to a node here. Since we've made all of our changes, we are going to click download, and it will download it to the controller. It's going to ask if you want to save it. We're going to say yes. Click OK. It's giving us a warning that we're doing a partial download. Could affect our process. We don't have anything connected. We just have our Fluke 725, so we're good to go. Click yes. It's downloaded everything. And now what I'm going to do is we're going to go online so we can see live values. Click online. Oh, and I just realized we forgot to do one thing. We forgot to set up our AI and our AO blocks. So the analog input block, you can see it was outputting 0 there when we went online. We need to point it to the right input. So select that. We need to find the IO in parameter, which is right here. Double click on IO in. Click browse. Drill down to our controller, and there's the level transmitter that we'd already enabled, LT-100. Click OK, and then click OK to this window as well. Click on the AO block parameter, or AO block, sorry, and we're going to find the IO parameter, which is right here. Double click on IO out, and click browse. Double click on our controller, and we want LV100, level valve 100. Click OK, and we are good here as well. Alright, so now we should be good to go. So let's do a download. Click OK. And we're going to go online. Alright, that looks a little better. You can see we have a value of 50% coming in. That is because right down here on our Fluke 725, we are sourcing 12 milliamps into the analog input right here on our DeltaV trainer. So on a 4 to 20 milliamp range, 12 is going to be 50%. So you can see we have 50 coming in. So what I want to do now is let's put this controller into automatic. We're in manual right now. So we need to find the mode parameter. press M, brings us to mode. See, it's in manual. So to change it, it brings up this menu for us. Properties for mode. There's a drop down right here, a target. Change that to auto. Click OK, and we should see that switch to auto. There. So now we're in auto. What we're going to go and do is adjust our set point. Where's set point at? There it is. We're going to set it to 50. It was already there, I guess. And what you can see now, we have 50% for a process variable, and I just changed our set point to 50, so we should have 0 error. That means when we have 0 error, we should have our biasing being outputted from our controller, which is 50%. So we have 50% being sent out. And let's just go over to the board here quick, just to do a quick talk on that calculation. So going back to the controller output calculation, you can see on the left here we have CO as controller output is equal to the biasing plus the proportional gain, which we set to 1, times the error. Since we're working with a direct acting controller, the error calculation is process variable, or PV, minus the set point, SP. So to figure out our error, you can see that we go 75 minus 50 times 1 plus 50 is going to give us 75% output. In our case, our set point is at 50, our process variable is at 50, that is equal to 0. 0 times 1 is 0, plus 50 would give us 50% out. So that's what we're seeing right now. If I go back and change our process variable to 75%, we should see our controller output change to 75% as well. So let's go ahead and do that quick. Alright, so I'm going to change our process variable by increasing our sourced milliamp value to 16. You can see you should watch this should change. This went to 75, and so did our controller output. So we verified the operation of this calculation by using that controller output calculation and applying it here in this DeltaV control system. So there's many other things that you can do with this block, and I just kind of wanted to demonstrate the very simple controller output calculation used here in DeltaV.